Good morning, friends and dear students. It gives me immense pleasure to come again for my course, Aircraft Systems. This course belongs to the 6th semester Aeronautical student. I am in the process of ending this course. I have already completed module up to module 5, 1, 2, 3, 4 and 5. Also, I have done some case studies and now I am in the second module of definition and the terminology. This definition and terminology belongs to the aircraft electrical and air conditioning system. Before that, I have just now completed the definition and the terminology of the module 1, which consists of introduction to aircraft systems. In that definition and the terminology, I have explained about the parts of the aircrafts, different parts, their functions, their definitions, also the navigation equipments, avionic equipments, communications, these all things, electrical, these all things I have discussed in my just before the completed my topic, definition and terminology. Today I am going to discuss about module 2, and in this module 2 I am going to discuss about aircraft electrical and air conditioning system. So in this definition I will take few key words of this module, and I will try to explain as much as I can do. As you know, my name is Dr. Dwivedhi. I am professor in Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, and I have worked in aircraft systems more than 20 years in Indian Navy. So I feel really very good to explain this aircraft systems, and I feel proud to be here as the instructor of this aircraft systems. So today I am going to take the aircraft electrical and the air conditioning systems, only definition and terminology I am going to discuss, not much in detail. So here topics and the CO mapping, electrical power generation, and the course outcome is CO2. We have different types of electrical power generation. It is also part of the CO2. Then we have some controlling of this power system, part of CO2. Then at the final, I will go for air conditioning and then I will end my lecture here. So first I am going to discuss about define electrical source. So what are the sources and how these things are distributed. So the electrical equipments which produces, converts or transform electrical power is called the electrical sources. Some common AC sources are identified as AC alternator, inverter, transformer and frequency changers. So we can divide this electrical source into two groups. One is AC group, another is the DC group. So those equipments which are able to produce, converts or transform from one form of the power to another form. The first one is the alternating current source. This alternating current source are obtained from the AC alternator. We can also use the inverters. We can also use the transformer. We can also use the frequency changers. Some common DC sources are DC generator, converter and the batteries. Okay, so for the DC we have the DC generator, here we have the AC generator, here we have the inverters, here we have the converters. We cannot use transformer in DC system, so we use the batteries to accumulate the DC power. So these are the basic electrical sources. Next is define primary or main power source. This we can see here. I have not mentioned the So a primary source is equipment that generates electrical power from energy other than electrical and is independent of any other electrical source. So primary source means that equipments that generates electrical power from energy other than electrical. Means if we are generating the electrical, we can use the mechanical power. And this mechanical power from where? We can get the engine, and engines are generating from the chemical. Your fuel is the chemical burning. It burns, it gives the heat energy. This heat energy is converted to the mechanical energy by the generator, and these generators will produce the alternating current or the DC current. These generators are shown here. These two types of generators, and these are rotated by the help of the engine or some motors, and they will generate the electric power. Mostly they are attached with the gearbox of the engine. And here also the same thing, the shaft will enter inside, and this will be rotated by help of the engine. It may be the piston engine, it may be the turbo engine, or any type of engine. Most of the time primary power is generated by the engine. It takes the power from the engine, and here will be alternating AC generator or the DC generator. These AC or the DC generators are used to generate the main power of the aircraft. So this is called the primary or main power source of any aircraft. Now we are also having some other systems. So it is called the secondary source. So in the secondary source, if you see that a secondary source is equipment that transforms and or converts primary source power to supply electrical power to other AC or DC power equipment. So in the secondary, it will take the power from the primary, which itself is the electric power. But if you see the primary is not taking the electrical power. It is taking some heat power or some rotation from the mechanical power, and this mechanical power is converted to the electrical power. But the secondary one takes the power from the main source, which is maybe AC or the DC power equipment or the AC and the DC generator. From there, they will take the power and they will convert. They will change the voltage and other things as per the requirement, and they will give to the other necessary equipment. A secondary source is entirely dependent on the primary source and is considered part of the load of the primary source. So they will take the power from the primary source. This primary source may be from the AC generator or the DC generator, and they will convert as per the, and this AC and DC generators are producing the power as per the given rating. Like AC, normally we supply with 115 volt AC and 400 hertz. But sometimes we need AC DC of 20 volt we need. So there will be a UPS, and this will convert from 115 volt to 28 volt DC. So like this, we are these secondary sources are used to convert from one part to another part. Next is what are the energy power sources? So emergency power sources. So this we have to see that most of the aircraft, if you see here, these are the ram air turbine. These ram air turbines are fitted near the nose of the fuselage. This you can see here, and they are lowered here by the pilot. As and when the main generator is failed, that time these things are lowered, and this will start rotating like this, and this rotation is attached with a AC or DC generator, and this AC and the DC generator will give supply for the emergency system. If you see here the location of this thing, this is the aircraft. It is flying like this. All of a sudden, both engines failed. But engines are failed, but we have to land. The landing gear has to open. Our emergency navigation system, your communication system, all electrical system have to work. From where they will get the supply? So we need some emergency system. So here I am showing the two emergency system. One is the ram air turbine, which is shown here. This you can see here. It is a ram air turbine. This one. This ram air turbine is located below the pilot. Pilot has got one knob. It will operate, or it is automatically also. Nowadays, if your main system failed and power requirement is reduced, it will sense that now we need some additional power, and so this will automatically come out. After coming out, it will start rotating. This you can see, it is like a propeller here. This propeller will start due to the windmilling. This started windmilling, and it is connected this thing with here a generator. This generator will give power to emergency bus bar. This emergency bus bar will supply the power to only emergency requirement, not for a general purpose requirement, like landing gears, your navigation, your communication. These all things you have to work, because you have to inform to ATC. So if it is not working, you cannot do anything. So these RAT systems are used most of the passenger aircraft where these things are used. So one is the RAT, another is the battery. Two are the main emergency power supply for any aircraft, and sometimes we also use the APU also, auxiliary power unit, if both engines are failed. So in the event of primary power source failure, so what are the primary sources? Emergency power is usually provided from independent auxiliary power unit, APU, driven generator, ram air or hydraulically driven generator, or battery. So this I have not shown here. Actually, I am supposed to show here. One APU is also there, auxiliary. So one, battery is 2, and this is the 3. These 3 systems are called the emergency power source on aircraft. A small aircraft will not have the APU also, and they will not have the RAT also only, but every aircraft will have the battery. Battery is used for 30 minutes. Battery can give power supply for the 30 minutes in any aircraft, so that it can land at the earliest opportunity. So these are the power sources, and if the main engine and your main engine fails, your primary alternating current generator, your DC alternating DC generators are failed. That time either power will be given from the APU, auxiliary power unit, or it may be given by the ram air turbine, or it may be given by the battery. Battery is in all the aircrafts. APU and this RATs are not there in all the aircrafts. Most of the bigger aircraft, they have APU also. We have the RAT also, and also we have the battery also. So now I will discuss about ground power source. You know that once the aircraft is flying, and before flying on the ground, we need to do lot of maintenance work, lot of other things. Servicing is done, engine testing, your system testing is done. That time we don't start the engines. If we start the engine, the fuel consumption of aero engines are very huge, and the life of the engine will be also reduced. Because as much you are using the engine, as many times you are starting the engine, there is automatically inside, it will be recorded how much your engine is run, and you have to perform maintenance. And also there is certain life after that many hours of the flying, that engine has to be rejected. It may be working, but you cannot use the engine if on paper the aircraft engine life is expired. So we need on the ground, we need some ground power sources. These ground power sources this is for a small aircraft. Small aircraft, it is a power trolley. It is called power trolley. Its part of the ground support equipment. It is a GSE part. This is also a GSE, but it is, you cannot handle. For this you need a mobile vehicle, maybe a truck or the tractor. Then it is towed to the tractor and it is taken near the aircraft, and from here these are the power supply cables. These cables are taken from here and they are attached to the aircraft. Okay, so it is like this. This aircraft is parked here on the ground. This is the truck here. Truck will come nearby and here will be a power charging point. These cables are taken and attached here. Okay, push inside and this power will be available on whole aircraft during on the ground. This will, it is like a generator, a big generator. This generator is started. This is like a generator. Same power rating as of the aircraft generator. This is diesel operated. It will start. All the voltage and all loads are monitored here so that it should not generate a false power, and aircraft should get the sufficient power which is required for the operation of the your starting system. Your other systems are used in this aircraft. Next, I am going to discuss about evolution of electrical power. So from 1950s onwards, because first time the Wright brothers has used it is called the Flyer 1. The first aircraft, December 3rd, I think this is 17th December, okay, 1903. They have flown in Kitty Hawk. Okay, so they have flown, and after that, there was need for the modern electrical system and how these systems will work, how it is useful for different types of systems, and how these things is evaluated. That is to be taken care of, and how this thing has developed. So this you can see that in 1950, the 112 volt systems were, DC systems were there, and here we have 115 volt AC, narrow variable frequency. Here we have twin 28 volt DC. So in this era of, we have like this, and like this, we have different voltage systems. Further, if you go next decade, 1960, in 1960 there are only 115 volt AC. New thing has come, 400 hertz constant frequency, and here we have also have 115 volt AC, 400 hertz constant frequency parallel. Two engines have started, two systems have started. This is still used. This system is still used. 115 volt AC and 400 hertz constant frequency is still used. But up to 1960 to 1980, there was only this system. After 1980, it has started to 1990. In this 1990, if you see, load management systems and multiple backup generators are used. These load management systems are operating. In this, multiple backup generators are used. As you go to 1990 to 2000, a very specific development has taken place. 270 by 350 by 540 volt DC has been developed. And this is the modern power requirement. This is the modern power requirement. And this 270 volt DC is used nowadays for F-22 Raptor and F-35 fighter. Name is Lightning aircraft. These things are used. The advantage of this 270 volt DC is that the electromagnetic interference in these systems will not be felt. The radar signature or the transmitting power, the radar will capture this, your electromagnetic waves, which is generated from your AC current, and this is not good for a stealthy aircraft. So especially for fighter aircraft, US origin fighter aircraft. So US origin fighter aircraft, they use 270 volt DC, and these are the few advantages which we have given. Also, this gives light in weight. Your conductors, the size of their wires will be reduced, and these are the few very specific advantages. So these advantages are used for the modern aircraft development. Next, we have to discuss about voltage regulator. What is DC voltage regulator? We know that the shunt generator voltage to drop with increasing current and output voltage should be constant, because we need a constant voltage. A voltage regulator is used to modify the current so that voltage is maintained constant. So the purpose of this thing is to maintain a constant voltage. So we need a constant voltage on the aircraft for the safety and the proper functioning of the aircraft. Here is the generator. This generator is producing, and due to the RPM and all, there is chances of fluctuation of the voltage. Here we have the one resistance. Here resistance. This will vary the position. If you want voltage increase, you make it up. If you want to decrease the voltage, you have to put down. Suppose we want a 200, just I will see that 115 volt DC you want. This volt, and here you are producing 125 AC, not DC, AC. So if you are producing this, so I want to reduce. So I will shift from here to here. So in this, if I am putting, I will get 115 volt AC supply. So like this DC voltages are regulated, DC voltages are modified, and accordingly we are getting the power by a constant voltage power supply by using the DC voltage regulator. Here all are the DC. All are the 28 volt DC. Okay, so accordingly it has to maintain. Now, what are types of power used in aircraft? Just now I have discussed about something, but here I am going to discuss in detail that different types of power supply used in aircraft. So here we use, here is the engine. From the engine we go for the constant frequency integrated drive generator. So this type of generator will produce constant frequency, and this is happening by the integrated drive generator. This integrated drive generator will give a constant speed, so you will get the constant power supply. So constant frequency is maintained especially for the AC power. So here we have 115 volt AC, 3 phase and 400 hertz. So this is the first type of the generation of the power, and this can be generated by CF IDG. Next we can generate constant frequency, variable speed constant frequency. This can be by the cyclo converter, or this can be made by the DC link. So this cyclo converter generator is converting to constant frequency AC bus bar. It is giving. Here also the DC link is also giving to the power to the generator, and a constant frequency of the power can be obtained. If you see here, we have the variable frequency generator, and this variable frequency generator will supply power to the generator, and frequency can be varied. The range of the frequency, it can be to 380 to 760 hertz of the frequency. It is a nominal range in which the different frequencies are generated, and here this type of generators are used. It is called the motor controller. They are controlled by the motor. Another very important for the modern aircraft is 270 volt DC supply, and this is nowadays used for all modern fighter aircraft, especially the US origin. This type of voltage is very advantageous. It reduces the weight of the generator, it reduces the weight of the conductor, and also it is very safe as a stealthy aircraft. Next we have the DC emergency power. It is also available, and I have shown that either the battery, then RAT, and then APU. These are the 3 emergency, and they will supply 28 volt DC for the requirement of the aircraft. So these are the few types of the power available on the aircraft. We should know this thing, the AC, DC, and the emergency. Next is the defined constant frequency system. So what is the constant frequency system and how it is defined? So here we have the IDG. So here constant soft speed it is achieving. Here variable engine speed. Normally engine speed will vary as per the load and all. Here we have the constant speed drive. It is called IDG. The combination of these 2 equipment, which is called the constant speed drive and the generator, it is called the integrated drive generator. The purpose of this constant speed drive is to take the power from here, and it will make sure that generator is getting a constant RPM. So by this constant RPM, it will supply a constant frequency, 3 phase A, B and C, 3 phase, 115 volt AC and 400 hertz of the supply is obtained by this constant frequency system, and this equipment is called IDG, integrated drive generator. So the feature of this thing is constant frequency AC power is most commonly used on turbofan aircraft today. System is expensive to purchase and maintain, primarily due to the complexity of the constant speed drive. CSD is very costly. Single company monopoly on supply of CSD and IDG. Only one company in the world they are able to make. Alternate methods of power generation are under consideration. So due to the monopoly of the one company, the cost is increased. So alternate methods of this thing is looked after. Next is the defined variable frequency system. So in this variable frequency system, if you see 380 to 720 hertz frequency I want. So variable speed engine drive approximately 2:1 for the turbofan. Here is the generator, and so we use another frequency range of 115 volt AC, but power the frequency may range from 380 to 720 hertz. So what are the basic important features of this type of system. Simplest form of generating power, cheapest and the most reliable. Variable frequency has impact upon other aircraft subsystems. Motor controllers may be needed for certain aircraft loads. Beginning to be adopted for new programs. Gains outweigh disadvantages. So this is the disadvantage of this type of aircraft. This is also disadvantage. This is also a disadvantage, which was not in the previous one, but this is the advantage. This advantage is there. By this three we have to look after, and then only we have to use such type of equipment. Next type of thing is variable speed, constant frequency. So here we have the generator. Variable speed, shaft speed, approximately 2:1 for the turbofan. Here we have the unit. It is called the variable speed, constant frequency, VSCF unit. It consists of a generator. From the generator, it goes to the converter. This converter is making sure that a constant frequency of 400 Hz, 3-phase of supply and 115 volt AC power is obtained. It is an electronic equipment. This electronic equipments make sure that we are getting a constant frequency, 3-phase and 115 volt AC power supply is obtained. So we have the features of this thing is conversion of the variable frequency electrical power to CF is accomplished by electronic controlled power switching. DC link and cyclo converter options are available. Not all implementations have proved to be robust, reliable. Cyclo converter shows most promising. So cyclo converters are used. I have shown you, I think in this previous, here we have the cyclo converter here, this one. This is the cyclo converter which are used in this type of system. So here DC link and the cyclo converter options are available. Not all implementations have proved to be robust, reliable. Cyclo converter shows most promising, is still unproven in transport market. Still it is in the research zone and not 100% applied for all the aircrafts. Define the reverse current over and under voltage protection system. So this reverse current, this is usually achieved by means of reverse current circuit breaker or the relay. So we use this CB or some relays. These devices effectively sense reverse current and switch the generator out of circuit, thus preventing any ensuing damage. So if the current is moving from one direction to another, there is chances of short circuit, and this should not happen on the generator. So if it is like this, in between we have to use the circuit breakers or the relays. These things are able to protect the system from reverse current area. Over voltage protection, how we can do? Over voltage protection sensed these failures condition and open the line contactor, taking the generator offline. So if there is over voltage or over thing, so there is some systems, these systems will protect from the over voltage, and same way if it is the under voltage, and under voltage protection capability is essential, as the equalizing circuit is always trying to raise the output of a lagging generator. In this situation, the under voltage protection is an integral part of the parallel load sharing function. So we have to ensure that our generators are safe for the reverse current. Also, if over voltage, we have to maintain a constant voltage, but sometimes due to some errors in the system or some short circuit in the system, over voltage may happen. So we should try to protect our generator. We should have some arrangement that your circuit is broken for under and the over voltage situation. Voltage regulations. The subject of AC generator excitation is a complex topic for which the technical solution vary according to whether the generator is variable frequency or the constant frequency. Some of these solutions comprise sophisticated control loops with error detector, preamplifier and the power amplifier. So we should have the control loops, preamplifier and the power amplifiers are used for the voltage regulation of the AC generator or the DC generator. Parallel operation. AC generators are operated in parallel to provide no break power. This is for the constant frequency AC generator only. This is not possible in variable frequency AC generator. Few systems like anti-icing, de-icing are frequency sensitive to and no break power needed. The generator output voltage depend upon the relevant performance of the voltage regulator and field excitation circuitry. So what is the constant frequency IDG? Actually this I have explained just now, but again I am just going to discuss about this constant frequency integrated drive generator. Constant frequency AC power is most commonly used on turbofan aircraft. Today's system is expensive to purchase and maintain, primarily due to the complexity of the constant speed drive CSD, single company monopoly on the supply of the CSD IDG. Alternate method of power generation are under consideration. So here we have one CSD. This CSD is very complex equipment, CSD. So it gives a constant drive supply to the generator. As the power is constant, you will get a constant frequency and the constant voltage very easily, and this is called integrated drive generator of aircraft. Then we have the variable frequency IDG. The features of this thing is simplest form of generating power, cheapest and the most reliable variable frequency, has impact upon other aircraft subsystems. Motor controllers may be needed for certain aircraft load, beginning to be adopted for new programs. Gain outweigh disadvantage. So this gain outweigh is the disadvantage of this type of system. Here we have the variable speed engine drive, approximately 2:1 variable speed drive may be accepted. It will go to the generator. From here you will get a constant voltage but varying frequency you are going to get on this system. So this type of very simple system, but it is not so accurate. Your chances of failure of the systems where this power is used may increase. To that sense, your weight of the system, your wiring, your wire weights, the size of the wire will be more, and in this way the weight of this thing will be higher. Now I will discuss about some air conditioning system. So here I am going to discuss about define RAM and the fuel cooling. What is the RAM cooling and what is the fuel cooling? You know that the aircraft is flying with a high speed and outside there is sufficient amount of air is available. This air, when it is entering inside the aircraft, some nozzles or some ducts, this will give a ramming effect. Little pressure will be increased. So this type of cooling, when it is, this air is passed from a heat exchanger, and that time it is called the RAM cooling. So the RAM air cooling, the use of RAM air is as a cooling medium has its limitations. Since RAM air is temperature increases with air speed and soon exceeds the temperature required for the cabin and the equipment. So this for low speed aircraft. For low speed aircraft, this type of system is good. But if you are going for the high speed, then what will happen? If aircraft is flying like this, so the pressure of this RAM air will be more. And due to this high pressure, temperature will also increase. So the cooling capacity of the RAM air will be reduced. So this ram air will enter into the heat exchanger, and this charge is supplied from here, and it goes like this. It will pass from here, and due to this, there is a fan. This fan will suck this air, and this air will go out. We have here jet pump flow from ECS. This is the primary fluid. So like this, ram air cooling is done. But sometimes what happens, this ram air is not suitable for all the system. In our aircraft, we have oil system, we have the hydraulic system, we have some other systems are there. Especially for the gearbox and engine oil system, they are going with a very high temperature zone. The oil temperature is increased very much. So only air cooling and this ram air cooling is not sufficient to make sure that your oil, engine oil, gearbox oil or the hydraulic oil is cooled properly. We have to use our fuel. The fuel which is available in our fuel tank in a very huge amount. And also if we are, and oil is in a few liters, maybe 10 liter or 20 liter oil which is supplying. But if you see the fuel is in tons. So this fuel can be used for the cooling of this type of system. And here this you can see here. The fuel is supplied from here and oil is entering here, and slowly it will pass from the heat exchanger of this. Fuel is here and it will go to again to the return line. This is the return line and this is the pressure line. So this type of system, and this fuel also goes to the engine, because if you are supplying a hot fuel in the engine, the burning quality of this thing will be increased. So we are getting the benefit from both the side. So that is why the heat exchangers are used, where we can use the advantage wherever we want. But same time, we should make sure that the fuel should not increase from a certain temperature. Otherwise, it will start evaporating and it will start burning. So that is also not permitted. So we have to make sure that type of things to be acquired. So now we have the engine bleed system. We know that in aircraft, we have the air conditioning, we have the pressurization system. This air conditioning and the pressurization of the cabin hot air has to be taken from some place. This hot air mostly is taken from the compressor stage, from the low and also low pressure side, and from the high pressure side. Both are mixed. So this high pressure and high temperature air is taken from the engine. This air is called the bleed air. The main source of conditioning air for both civil and the military aircraft is engine bleed from the high pressure compressor. This provides a source whenever the engine are running. The conditioning air is also used to provide cabin pressurization. So this is used for the conditioning of the air, and the pressurization of this thing is used. This you can see here that air bleed from engine. This air is taken from the engine and this is going to the ejector, and air cooled flow. It is coming from here and it is going from here. So at different systems we can use the bleed air as it is shown here. What is APU? Auxiliary Power Unit. It is a big, it is a small engine, and it is fitted mostly on the vertical fin behind the system, and as and when it gives as a emergency power supply, and on the ground, if ground stations are not available, this can be used to start the engine. So that is the purpose of the auxiliary power unit. Most often the auxiliary power units power is used while the aircraft is on the ground during the maintenance or for engine starting. However, most aircraft can use the APU while in flight as a backup power supply. So as emergency power supply also we used. I have discussed just now before few slides. One exception to this is B727, which only allows APU operation in the ground. So this is depend upon the manufacturer how they have designed. So the Boeing 727, this aircraft is only used for the this operation only on the ground. So here I am showing some APU. This is the APU here, and here it is shown on the vertical tail. This is the APU. Installed. It is exhaust. Here this is the total APU here. It is a small gas turbine engine which is light in weight and which is fitted on the aircraft. Now, integrated drive generator, IDG. Another method of regulating the generator speed is with the use of integrated drive generator, IDG. And IDG is simply a constant speed drive and generator combined into one unit. There are two ways to mount the IDG, coaxial and the side by side. So I have shown you that how these IDGs are working. So here we have the CSD and here we have the G, and it is coming the engine power from here, and here you will get a 115 volt AC 400 Hertz 3-phase power supply you are going to get by this system, which I have already discussed in detail. Here we have another equipments, transformer rectifier unit, TRU. Transformer rectifier units are utilized to 115 volt 400s into a 28 volt DC. It is a converter which converts 115 volt AC to 28 volt DC supply for the aircraft. A transformer is used to reduce the voltage from 115 volts to 200 volt DC. So for this we need a transformer. This is the transformer which is converting 115 volt to 28 volt. At this point the 28 volt is still AC current. This, to change the current from AC to DC, we need a rectifier. So we should have a rectifier here. So this is called the transformer and the rectifier. This rectifier makes that it is converting from AC to DC, and also 28 volt AC to 28 volt DC. Each aircraft AC bus feeds a TRU which feeds a DC bus. So this is from AC bus, it will convert to the DC bus. Transformer rectifier unit, it is shown here, used to convert to DC current. Typically 28 volt DC it is converting. So that is called the transformer rectifier unit. So these are the references which I have taken here. Moir AI and the Seabridge aircraft systems, mechanical, electrical and avionics system, Professional Engineering Publishing Limited, London, and Bury's St. Edmund, UK, ISBN 1. Another book for this is Design and Development of Aircraft Systems and Introduction, AIAA Education Series, AIAA 2004. If you have any questions, you are welcome to ask. I will feel very happy to reply. This is my email. You can mail me, I will be replying. Also, you can give the comment. Also, like it and subscribe this channel. Hope this thing will be very useful for you all. And if anywhere you feel that it is having some problem or some not proper, you are welcome to revert me. I will try to rectify myself. It is not that everything that I am telling is 100% correct. But as far as I have some knowledge, as per that I am explaining that aircraft systems. Thank you very much for the joining, and please be tuned for my next class. I am going to discuss again few definition and the terminology. The next topic will be in hydraulic system. Hydraulic and the pneumatic system I am going to discuss in my next class. Thank you very much for the joining.
Like, share and subscribe. Hit the bell icon for more updates.